Hello guys, so we are going to continue the discussion with respect to our linear algebra. In this video, we are going to discuss about two topics. One is magnitude of vector and the other one is something called as unit vector. Now, whenever I talk about magnitude of vector, I am basically talking about vector length, okay? And if we go ahead and discuss about unit vector is nothing but here the vector has a length of 1, okay? So we are going to discuss about this. First of all, we'll try to understand how do we calculate a vector length, okay? Let's consider that I have a vector that is x, okay? Let's consider this as my vector x, and vectors are usually denoted by this arrow mark. Let's say that it belongs to this real values of n dimension, okay? It can be of any n dimension. And let's consider that I have values like x1, x2, x3 up till n dimension xn, okay? Now, just to give you an example, if I just go ahead and let's consider that I have an x vector which has values like 2, 3, okay? Which has these values 2, 3. Now, if I go ahead and see with respect to the coordinate system, 2, 3, where does it come, right? Let's say this is my x-axis, this is my y-axis. When I say x and y-axis, let's consider I can also rename this particular vector as A, okay? This is my x-axis, this is my y-axis. Now, with respect to the x-axis, if I go ahead and plot it, let's go ahead and plot it. So this is my 2. And similarly, if I go ahead and plot in my y-axis, this is my 3, right? So if I go ahead and join this, this is my data point that I'm actually getting, which is denoted by 2, 3. Okay. Now, when I say I need to calculate the magnitude or the vector length, I'm basically calculating this distance from the origin, which is in this direction. Now, in order to compute this, what we do is that we basically use a simple Pythagoras theorem, right? Let's say this is my Pythagoras theorem over here. And over here in the x-axis, you have this, right? Now, according to the Pythagoras theorem, if I just go ahead and consider this as O, A, and B. Now, here we need to calculate OB, okay? OB. This OB is nothing but it is also, you can also specify this as it is the magnitude of vector A, which is given in this direction. So, I'm considering this as my vector, right? So, OB will be nothing but it will be equal to square root of, according to the Pythagoras theorem, square root of, right? We will take OA square plus OB square, right? Now, what is OA square? OA square is nothing but whatever is the value in the x coordinate, it is that, right? So, I will be having, I can also go ahead and write this as, let's say that this is my x1. If I denote this as x1 comma y1, it is nothing but x1 square plus y1 square, right? Now, if I go ahead and just put these values, it is very simple. My x1 square is nothing but 4 and my y1 square is nothing but 9. So finally, I get the value as root of 13, right? 4 plus 9. And root of 13 is nothing but is my magnitude of vector A. When I say magnitude of vector A, that basically means this length, okay? Now, if I go ahead, this was with respect to, it belonged to the real values of 2 dimension, right? What if I have another vector A or another vector B? Let's consider this as my another vector. And let's say that this is now having 3 dimension, x1, x2, x3. Let's consider this is my 3 dimension. Now, in this scenario, my magnitude of B can also be represented as square root of x1 square plus x2 square plus x3 square, right? The same thing, right? Like how we had x1 square plus y1 square because we are considering x and y axis, right? So if you want to write a generic formula, let's consider this with respect to this particular magnitude. If I want to find out the magnitude of vector x, it is nothing but it is square root of, with respect to this x1 square, x2 square, I will just go ahead and write x1 square plus x2 square plus x3 square plus like this up till xn square. So this is the formula that we specifically use in order to calculate the magnitude of a vector, which is nothing but it is representing the vector length. Okay, so this really represents the vector length. Now, but still we have this unit vector, right? So whenever we talk about unit vector, let's say that I'm going to consider this u as my unit vector. Okay, if this is a unit vector, this length needs to be 1. And whenever we have a unit vector, we also denote it as, this entire notation for a unit vector can also be represented by using this. In most of the textbook, they use this, right? U, on top of it, you have this particular symbol called as cap. Okay. Now let's go ahead and understand how do you basically calculate a unit vector of any vector also. Okay. Let's say that I have a vector which is like v. Okay. This vector is denoted by v1, v2 up till vn. Let's consider in this way. Now we need to change this into a vector, into a unit vector. Okay. First of all, we'll need to change this into a vector called as u. And this vector, if I go ahead and calculate the magnitude of u, it should be equal to 1, right? So then we can basically say this is unit vector altogether. Okay. So in order to do this, we specifically use a very simple formula, which is nothing but u vector is nothing but 1 divided by magnitude of v vector multiplied by or dot product by v vector. Okay. So this is the formula that we specifically use. Now, one very important thing over here is to understand, and obviously you would like to solve this with a very simple example also, right? And how this entire magnitude is basically calculated, right? So let's go ahead and do this. Okay. So here, if I use this particular formula, let's calculate this particular formula. Right now, I'm just doing this transformation by using this formula. Okay. I'm just calculating the u vector over here. Now with respect to this u vector, let's consider that my v vector is nothing but, let's consider that I am using this as a 3 dimension. It can be 1, 2, 0. Okay. And this belongs to a real value of 3 dimensions. Okay. Now I will use this formula u hat. Let's first of all go ahead and calculate magnitude of v vector. In order to calculate the magnitude of v vector, I'll just go and write square root of 1 square plus 2 square plus 0. It is nothing but square root of 5. Okay. Now we will go ahead and replace this particular formula over here. 1 by square root of 5 multiplied by whatever vector we have, that is v, right? And here I will do a dot product with respect to this. Okay. So when I say dot product, this is a scalar multiplication. Okay. This is a scalar multiplication. It is not dot product here. Specifically, this is a scalar multiplication. Okay. Since we have one value over here. So once I do this, I will finally get nothing but 1 by root 5, 2 by root 5, and then I have 0. Now, since we know that this is my u vector that I have got. Now, in order to calculate the magnitude of u vector, which is also denoted by unit vector, okay, we will just go ahead and verify whether this formula will come right or not. Again, still I should not be writing this u vector here itself. First of all, we'll go ahead and just calculate this. Okay. So let's go ahead and calculate it. It is nothing but 1 by root 5 whole square plus 2 by root 5 whole square plus 0 whole square, right? So it is nothing but over here, you'll be able to see 1 by square root of 5. It is nothing but 1 by 5 plus 4 by 5, right? Plus 0. So if I go ahead and calculate this, I'm going to get square root of 5 by 5, which is nothing but 1. So if I'm getting this one, this formula basically proves that here we have got a unit vector. A unit vector is nothing but a magnitude of, well, the vector length is basically 1. And if you remember initially also when we discussed about this in the coordinate system, right? Let's say if this is my x and y axis, I had used one notation, right? Let's say I have a data point which is like 2, 3. Let's consider this data point. So this is my 2 and this is my 3, right? And this is the point if I'm getting, right, 2, 3 with respect to the coordinate, right? I had also mentioned that we will consider the unit vector as this, right? So let's say this is my I hat, and this is my j hat, right? We can represent this vector also as 2I hat plus 3j hat, right? So this also indicates the same thing with respect to this particular notation. Here, this I and j are nothing but they are unit vectors. They are specifically unit vectors. So I hope you got an idea with respect to the unit vectors. This will be very handy because this will be very handy when we specifically do a technique which is called as normalization. Normalization, right? Normalization is a technique. Now, the reason is very simple over here. Whatever may be the vector size, right? If I really want to find out a unit vector, the length of the vector length will be 1, right? Vector length will be 1, right? So this kind of normalization technique basically means, let's say that I have some data set, okay? Now in this data set, let's say if I have this x and y coordinate, okay? This data set is in different scales. Let's consider it is in different scale. Let's say that I have a data set which says based on age, we have some weights, okay? Now you know that as the age increases, let's say the weight may increase, you may have different data points, right? And initially your data points may be starting with, let's say if I just consider the minimum age as 18, then your data points may start from 50, 60, 70, like this, right? All these data points are basically there. Now these values are very huge, right? So if I probably want to do a normalization over here, what I will try to do, I will just try to make sure that I'll convert all these particular vectors into smaller scale values. Let's say instead of 18 and all, I will just try to convert all these values between 0 to 1. So my values over here will be completely normalized in a smaller scale range, okay? Smaller scale range, so that whatever data points I have, it will be all plotted here itself instead of expanding till the end over here, right? And this sometimes is very important for some of the machine learning algorithms, because this will actually help you to improve the optimization process. How this is going to happen, when you will be seeing some of the machine learning algorithms, you'll be able to understand over there, right? So specifically in normalization, this strategy is used a lot, okay? Where we take unit vectors and we work along with that. So I hope you got an idea with respect to two important topics over here. That is nothing but vector length and unit vectors. This was it from my side. I will see you all in the next video. Thank you.